since we are going to use these two objects in a formula in our program further down here, then it's a good idea to create an identifier for each of them so you don't have to write them over and over again when you use them in formulas down here. An identifier will also help you as a programmer to know what that object is, because like this you don't know that this is a latitude. But if you use an identifier such as this and that, now you know that this is a latitude and this is a longitude. And so these are identifiers in Python, also known as variables. Still, this is the object. This is just an identifier, it's not the object. Now let's calculate the antipode of latitude. So now we know that it's a good idea to use identifiers, therefore I'm going to use an identifier for antipode latitude. So you can name, you can choose whatever names you want for identifiers, as far as you don't have spaces in the name. So you can use underscore but not space, and also you cannot start the variable with a number like that or that. And then you use the assignment operator, and then what we should do here is we have two choices. Either we get the original, the input latitude, copy and paste it in here, or, which is a much better idea, is we just use the latitude identifier. And this is what every programmer would do, but I'm just showing you that it's the same thing. So when you use the name of the object, the variable of the object, the identifier of the object, whatever you name it, it's the same thing as using that object in here. Now, the antipode latitude of New Zealand was the negative value of this. So if this is 40.09, the latitude of the antipode is minus 40.09. How would we calculate that in math in real world? Well, we could have a formula like latitude times minus 1. So in Python now we need to multiply the latitude object, this object, by minus 1. But how is an object multiplied? So now we are talking about interaction between objects. We are multiplying the latitude float type, this object, by minus 1. So we have an interaction between the float 40.09 and integer minus 1. So minus 1 would be an integer in this case. You could also use float, but it doesn't make much sense. So this is a sort of a gray area abstraction. I'm thinking, as Ardit, I'm thinking of abstracting it as an integer in Python. And so how does the interaction happen? Well, it happens through a method. You know, if you go to an interactive Python session and do dir float, execute that, you'll get all the available methods you can apply to a float object. One of them is underscore, so double underscores, mul, underscore. And if you use that method of a float object, the way to use it is by using a dot notation. So after the object, which could be either latitude, so the identifier, or the actual object, like that, you use a dot after that, and then you write the name of the method. So mul stands for multiplication, and it's a property, it's a method that is property of a float object. You'll see that if you use the help and do float, use the dot notation, mul, with underscores, leading underscore and ending underscores, and press enter, you'll see this documentation here. So mul actually uses this round parenthesis and gets some values known as arguments. So it gets two values. Self is actually a very special argument that underlies the object that the method applies to, which is the this object in this case. So this method gets as arguments its own object latitude, so you don't have to pass self. You can always ignore if you see self. And then you get the value. The value is the other object you want to multiply your first object with. And this is how every method works. And the other object is an integer with a value of -1. So that is the type of the object, that is the attribute of the object, and that is the entire object. Now be careful with the parentheses. These open and closing parentheses are for the attributes of the int object. You also need another closing parenthesis there to close the parenthesis of the method. You see the syntax? An open parenthesis, a closing parenthesis. Now, besides self and value, you could also see this slash here. But that is not an argument. The arguments are self and value. Slash is just part of the syntax to indicate that the argument before it, which is value, so the argument before slash, which is value, cannot be passed as a keyword argument. Now, a keyword argument is a concept that you will learn later, so it doesn't make sense to explain it now. So for now, it's enough to know that this slash here is not an argument. It's just there to indicate that value is not a keyword argument. We'll talk later about keyword arguments. And so what do we get out of this expression? Well, you can see here, return self times value. So this mul method is actually multiplication between the self, so the object that has the method, which is latitude in our case, and the value that you pass, whatever value you pass here, as an argument of the mul method. And that will create another float object. And the identifier antipode latitude will be referencing that float object. Now, why a float object and not an integer object? Well, that has to do with the hierarchy of numbers in Python. Because when you multiply a float object with an integer object, you get a float object as output. Since float is higher in hierarchy and it also includes integers, so to say. But you don't have to know about the hierarchy of numbers. That is only a concern for the people who actually designed Python. So this is what programming is about. You have some objects in mind, such as the coordinate of a point on the Earth's surface, and you want to know how to represent that, what kind of Python object you want, so float, and then everything else is an interaction between different objects in your Python program. And the way you do that interaction is through methods. And you can use the dir function here that we used to find out what methods you have available for that particular type of object, and then you use the dot to interact between the first and the second object, which is this here. And now we have the first output stored in the antipode latitude identifier. How do we get the results? You can use a function for that. So we have objects, we have methods, and we have functions. Well, methods and functions are also objects in their own world, but we'll talk about that later. To print out outputs, you use a print function. You see that the syntax is the same. So print mul, so it has this round parenthesis where you can input the arguments. So this was the argument of the mul method. The arguments of the print is what you want to print. Antipode latitude. You want to use the run button to execute the code. And if you haven't saved your script yet, you'll get this window where you can choose where you want to save the script, or alternatively you could have just press save. And then choose the folder where you want to save that file and pick a name for the file. I'm just going to use main1.py. So always use a .py extension after the name. Save, then run. And In Thonny, I'm going to get the output just here. So that is the output of this line in here. Now this is actually a float, but you don't see the complete representation of the float object. You just see a simplified representation, which is minus 40.09. So a more of a real world representation. So this is just for simplicity. Later I'll show you that we also don't need to write this entire object when you program in Python, but first it's good that we start from the very roots of the Python programming language, so you understand the concept. That is very important. We're not learning here how to multiply 3 by 5 in Python. We are learning what objects are in Python and how to make every kind of program, how to start it, how to use your logic, and how to abstract it into a program. In the next video, I'll show you the difference in concept between functions and methods.